recording this. Okay, so today we are going to do 5.1 and it's real short and sweet. So it's not going to take us much time at all to go through it, but I don't want to move on to 5.2 just because I don't want to overwhelm your weekend if you haven't done your chapter 3 review or chapter 3 test. Okay, because this Sunday, you'll have 3.5, chapter 3 review, chapter 3 test, and now 5.1. So I didn't want to add anything more to that. We'll just start with the rest of 5 next week. But I did want to get at least this little bit in since we did miss, that week for snow. So let's go through this. This chapter, starting at this chapter, chapter 5, is on exponents, okay? And some exponent rules. The first thing we're going to talk about is what the base is and what the exponent is. When you have a number or a letter, it doesn't matter, we'll just have x to the 5th power. This little number up top, that is called your exponent. The main part of the number right here, this is called your base. What the exponent does is it tells your base how many times to multiply times itself. So this exponent would tell this base to multiply times itself 5 times. So if I wrote this out, it would be x times x times x times x times x 5 times. Okay, so that's what the exponent tells you, is how many times to multiply your base together. Okay, so the first couple of problems are actually just naming who the base and who the exponent is, and then doing this work. So let's look at number 1. You've got 2 to the 3rd power. So the first thing it wants to know is what's the base. Then it's going to want to know what's the exponent. And then it says 2 to the 3rd power equals blank. So these 3 things. Okay, so the base of this term would be the 2, right? That's the main number. The exponent is the little number up top, so it's going to be 3. Then 2 to the 3rd power would mean 2 times 2 times 2. So if you wanted to write that out and then do that multiplication, 2 times 2 is 4, times 2 again gives me 8. The biggest mistake that people make on these kind of problems is instead of doing 2 times itself 3 times, they simply do 2 times 3, right? This doesn't say 2 times 3, it says 2 times 2 times 2. Okay? Let's look at number 2. -5 in parentheses to the 5th power. All right, since the negative is inside the parentheses with the 5, this whole thing inside here is your base. So your base is -5. Your exponent is 5. Oops. And then it wants to know, well, what is -5 to the 5th power? Well, that means to multiply -5 times itself. 1, 2, 3, 4, 5. Okay. Now remember, you can do these if you don't want to waste all that time doing all that multiplication out, you can just punch that in your calculator. So when you are using numbers in your calculator and you're raising them to an exponent, If it's a negative number like that with the parentheses around it, you're going to want to do that in your calculator. Okay, so here I would do open parentheses, the -5. Remember, the negative is below the 3, so -5, close. Now, to get up into your exponent, see this little up arrow looking thing? That puts your, watch when I've hit it, it puts my cursor up in the exponent. And then you put in whatever the exponent is, which is 5, and then hit enter, which gives you -3125. Okay, here's why I say, especially when your exponent is even, here's why I say if you have a negative number and it's raised to an exponent, and it's in the parentheses, you want to do the parentheses, because let's say we had this number. Let's say we have -2 to the 4th power. So let's look at what happens with the parentheses, but if I didn't put the parentheses. So I'm going to do it right first. So open parentheses, -2, close, go up into my exponent with the arrow, and hit the 4. So it gives me +16. If I don't hit the parentheses and I just do -2, go up into my exponent, and hit the 4, it tells me -16, because what you are telling your calculator here is that you want -2 to multiply times itself 4 times. So if you do that, it would look like this, right? -2 times -2 is +4. +4 times -2 is -8. And then -8 times -2, so it's negative times a negative, really is +16. What this is telling your calculator to do is to only multiply the 2 times itself 4 times and just bring down that negative. It's not including the negative in what is being multiplied together. So that's the difference. So if you have parentheses around your number, before you do that, you need to make sure you put the parentheses in your calculator. Okay? Now, the next thing we're going to talk about is our first exponent rule. We're going to talk about 2 different exponent rules today. The first rule we're going to talk about is the product rule. So what the product rule says is anytime you have the same bases that you're multiplying together and those bases have exponents, you can shortcut that by adding the exponents. Here's what that looks like. If you have x to the 7th times x to the 5th, you can rewrite this and simplify it by making this one term and adding their exponents. So 7 plus 5 gives you x to the 12th. So that's the product rule. Okay, so again, multiplying the same bases, the bases have to be the same. You add their exponents and simplify it by turning it into one term. So let's look at some problems that are using this. Number 3 says use the product rule to simplify the expression. And then it says write your answer in exponential notation, which means here's what the problem looks like. You've got 7 to the 5th times 7 to the 9th. So here, I've got the same bases. They're both 7s, which means I can simplify this by adding their exponents together, which would give me 7 to the 14th. And here's the thing. It wants you, what it means when it says leave your answer or write your answer in exponential notation is it wants you to leave it as an exponent instead of typing in 7 to the 14th power and seeing what that is. It wants you to leave your answer just like this, as an exponent. Okay, so that's what number 3 looks like. Let's look at number 4. Again, it's using the product rule. -2 in parentheses to the 2nd power times -2 in parentheses to the 3rd power. Again, it wants you to leave it in exponential form. Same basis, so -2 in parentheses, right? If you don't put the parentheses, it means something completely different. Add their exponents, so -2 to the 5th. That's number 4. Number 5. C to the 4th times C to the 6th times C to the 6th. All the same bases being multiplied together, which just simply means I'm going to add all of their exponents. 4 plus 6 gives me 10. 10 plus 6 gives me 16. So it's the C to the 16th. Okay, so this is going to help us later on if you are trying to simplify or solve something. It's much easier to look at something that looks like this than it is to look at this or deal with this, right? This is just one term with one exponent instead of a bunch of terms with a bunch of different exponents. Okay, so it's helping simplify these things. Right, number 6 says use the product rule to simplify your expression. You have -3 x to the 9th times 6x squared. So we're still multiplying. We're still using our normal multiplication rules. So this -3 times 6 is the same thing it's always been. These are simply exponent rules. They deal with nothing else but exponents. So -3 times 6 is still -18. Since I'm multiplying same bases, when I multiply these terms together, I can just rewrite that as x, add my exponents to get 11. Okay, now let's look at number 7, and then we will translate that into our second rule, which is going to be called the power rule. Okay, let's look. It just says simplify the expression. In parentheses, it's got 3 to the 3rd power and to the 2nd power. So before we do anything, I'm going to show you 2 different ways to do this and why the power rule is what it is. Okay, so let's just figure out what is 3 to the 3rd power. So you can either in your calculator do 3 times 3 times 3 or in your head, or 3 go up into your exponent 3. So if let's see, 3 to the third power. So inside that parentheses, I really have 27, right? Because 3 to the third means 3 times 3 times 3, which is 27. So that just took care of this part right here. I still have 27 to the second power. So I can still keep going further here. 27 times 27, right? That's what that's meaning. Or if your exponent is a 2, x squared has its own button. This button right here will just square the number for you. Okay, all the other exponents, you got to use the arrow. And you can use the arrow for the 2 also, but you can just use that if you want. So 27 squared gives me 729. Now, here's what I want to talk about on this, the power rule. What the power rule says, and I'll write it up there in just a minute, is if you are raising your base to more than one exponent, you can simplify that by multiplying the exponents together. So let's use this here, which means, again, I'm going to write out the power rule in just a second. Let's just say, so the power rule says if you're raising your base, which is this 3, to 2 separate exponents, you can multiply the exponents together and then just go from there. So that's saying that this should be the same thing as 3 to the 6th power by multiplying those exponents together. So let's type 3 to the 6th in here, and this should be the same exact thing. Okay, so let's clear it out. So 3, go up into your exponent, 6, hit enter, and there's your 729. So again, what the power rule says is if you are raising a base to more than one power, you can multiply them together to simplify it. So I'm going to write that out. So you can kind of keep a list of, especially this will come in handy when you're dealing with all the exponent rules together, like on your review and your test, to have just a sheet of paper that has all the exponent rules, so you can just refer to it. Okay, so exponent rule number 2 is the power rule. And it says, oh, I didn't even write out the product rule, I just showed it. We write it all the way out for y'all, so y'all can have your separate sheet of paper. So the product rule says, if you are multiplying the same bases, you add their exponents. So that's the product rule. Now the power rule says if you are raising your base to more than one exponent, you multiply the exponents together. at least I'll get that written down, and then we only have, okay, number 8 and 9 really is just kind of going over, it says the power rule, but what it's kind of going over is if you have a parentheses with an exponent on the outside of it, and your term has a bunch of different parts to it, like an X, Y, Z, that exponent goes to every single part. Like number 8 says, in parentheses, 8xy all to the 6th power. Now, this one is multiple choice, so let's look at our different choices. 48xy, 8xy to the 6th, 8 to the 6th, x to the 6th, y to the 6th, and 8 times 6, x to the 6th, y to the 6th. So what it wants you to do is pick which one that goes with. So again, anytime you have a parentheses with an exponent on the outside of it, that exponent goes to every single part. Everything in there is being raised to the 6th power. That's what the parentheses say. Include all of us. We all get the 6th power, which means 8 is to the 6th, x is to the 6th, and y is to the 6th. Okay? It does not mean 8 times 6, right? 8 to the 6th power is 8 to the 6th power, which means this right here is what you would start to work with, right? Everybody gets the 6 exponent inside there. Okay, then number 9, last one, says simplify this, and again it says type it in its exponent form. It doesn't want you to carry it all the way out. You have 8 over 7 to the 6th power. It's a fraction, but it's all in parentheses, which means who gets this 6th power? The 8 and the 7. So if I rewrote this out, the 8 would be to the 6th power and the 7 would be to the 6th power. And since it says to leave it in exponential notation or exponential exponent form, you're actually going to leave it just like that instead of trying to figure out what that is. Okay, I guess that'll come in 5-2, which hindsight's 2020. We should have done that today because we have all this extra time. But I am going to go ahead. Doing okay, Brittany?
Yes, ma'am. I'm okay.
Okay, I'm just making sure.
Yes, ma'am. Thank you, Ms. Hanson. You have a great day.
Thank you. Have a good weekend.
All right, you too.